of the neurotransmitters, as soon as they're released, they start getting sucked up by the presynaptic nerve. Some of them get degraded. Some of them get sucked up by the postsynaptic nerve. Just depends on what you're talking about. Any questions so far? All right. So, acetylcholine is released, binds to the receptors, opens these gates, sodium rushes in, sodium depolarizes this motor end plate, and then this action potential that started spreads down the T-tubule, hits this DHP receptor. It stands for dihydropyridine. We just call it DHP for short. Okay. It's going to hit this receptor, and this receptor is going to activate this little coil mechanism and open this little hatch door. Okay, it's like a little video game. Right, we have Super Mario Brothers, where you pin in a box and the coins keep jumping up. Once this DHP receptor gets excited, it changes shape. It's all protein, changes shape. Of course, it doesn't look like this in real life, but it is spiral. And it opens this little hatch door, and guess what gets released from the sarcoplasmic reticulum? Calcium. Calcium floods out of the sarcoplasmic reticulum into the cytosol, and that's where you get your calcium from. Once it's into the cytosol, where does the calcium go? Troponin. And then it causes troponin to move tropomyosin out of the way, out of the active sites, and then you have myosin bound back. Okay. So this is the whole excitable part. It's propagation of the action potential down the nerve, release of neurotransmitter, that's how they communicate. Neurotransmitter binds to ligand-gated channels, gets the motor end plate excited, the action potential is generated. It spreads down the skeletal muscle fiber in through the T-tubules and ultimately causes calcium release, which then binds to the troponin so that the tropomyosin gets out of the way, so that the myosin can then bind to the actin. The myosin binding to the actin, we call that a cross bridge. Okay. So myosin binding to the active sites of the actin is called a cross bridge. And this breaks it down. I have 3, 4, 5, 6, 7, so you can work your way through that. As you're memorizing this, you should memorize this chunk first, then this chunk, and then that part, and you can quiz yourselves, right, because I gave you the numbers. And then, just make sure. I'll come back to it though. Okay, so I want you to memorize these in chunks and then put it all together. You should be able to talk nerve to skeletal muscle to contraction to relaxation. Okay, so overview of contraction. How the heck does it work? Myosin, once it cross bridges with the actin, it's going to thrust or contract. We call this a power stroke. Okay, so it's going to contract and pull the actin in towards, I erased it, towards the end line, towards the middle. Okay, end of the power stroke, the myosin releases the actin and grabs another actin molecule. Okay, so myosin head, right, it links up with the actin. As long as calcium is present, it's going to notice that the myosin head is already activated, okay? It's already split ATP into ADP and phosphate. It's activated, it's ready to go. However, if calcium isn't present, you're not going to get any contraction, okay? So if the myosin head has already bound, let's say this is ATP, it's already bound the ATP and it's activated, it's not going to cross-link with the actin until calcium is present. Once you get an actin potential and once calcium floods the inside of that cell, then it will engage and contract. Okay? So you have to have ATP, but you also have to have calcium. If calcium isn't present, you're not going to get any contraction.
Because calcium binds to troponin.
In order
Yeah.
for
Okay.
myosin to bind to.
Okay, so it binds to troponin. Okay, so calcium binds to troponin and does what to the tropomyosin? Change the shape of it and moves it out of those active sites so that the myosin